Have you ever really stopped to think about gold? I mean, where does humanity's most prized metal actually come from? Well, the answer is way more dramatic and frankly, way cooler than you might think. So let's dive into this wild story of fire and stars. Okay, so first, let's head back in time. We're in the Middle Ages, surrounded by alchemists. You know the image, right? These guys hunched over bubbling pots, totally obsessed with what everyone thought was a crazy dream, taking a boring metal like lead and somehow turning it into pure, shining gold. But here's a wild thought. What if they weren't completely off their rockers? What if their quest, even though their methods were, a little misguided, was actually pointing to a fundamental truth about how the universe works? A truth they were centuries away from even beginning to understand. Because here's the big secret, the major twist in the story. The key to making gold isn't about some chemical recipe here on Earth. Gold isn't really native to our planet. Nope. To find where it's really from, you have to look up, way up. That's right. Every single atom of gold you've ever seen, every ring, every coin, every tiny flake, is extraterrestrial. It was forged in the most insane furnaces in the universe and then delivered here. Just think about that for a second. That piece of jewelry you might be wearing, it is literally, and I mean literally, stardust. And the delivery event? It's called a supernova. It's the spectacular, unbelievable, cataclysmic death of a giant star. This is the cosmic forge. This is where the universe cooks up its most precious elements, including our gold. So, how in the world does a dying star pull off the ultimate magic trick that the alchemists could only dream of? Okay, let's get into the physics of this amazing cosmic forge. For millions and millions of years, a massive star is basically a giant, stable fusion factory. Deep in its core, gravity is so intense it crushes hydrogen atoms together to make helium, which releases a ton of energy. That process just keeps going, building up heavier and heavier elements. Helium becomes carbon, carbon becomes oxygen, and so on, all the way up the periodic table until you get to iron. But iron is a dead end. Fusing iron atoms together actually sucks up energy instead of releasing it. The factory's engine just shuts down. And with that outward push of energy gone, gravity, which has been waiting this whole time, finally wins. The star begins to collapse on itself, and it happens fast. In these last frantic moments, the pressure is it's unimaginable. Protons and electrons, the fundamental little bits that make up atoms, are literally squeezed together so hard they merge, creating this incredibly dense sea of neutrons right at the heart of the star. Now, these neutrons are the secret ingredient. Because they don't have an electric charge, there's nothing to push them away, so they can just slam into all those iron atoms at an incredible speed. It's a process called rapid neutron capture, which is a great name for it. The iron atoms just soak up neutron after neutron, getting heavier and more unstable. And in a flash, they transform into all the elements heavier than iron that we know. We're talking silver, gold, all the way to uranium. And this is where the timing just gets mind-blowing. Look at this. A star spends millions of years turning hydrogen into helium. It takes thousands more years to get from helium to iron. But the creation of all that gold, it happens in just a few seconds, in the final moments before the star completely tears itself apart. All right, so the gold has been made. But how did it get from that faraway, exploding star into the ground right here beneath our feet? Let's follow the next leg of its incredible journey, the delivery to planet Earth. That supernova explosion is so powerful, it's hard to even wrap your head around it. It's like a cosmic cannon that blasts all those brand new heavy elements, including all that fresh gold, out into the huge empty space between stars. Over vast stretches of time, this cloud of cosmic debris swirls around and mixes with other gas and dust. Eventually, gravity does its thing. It starts pulling all this enriched material together, and a whole new generation of stars and planets begin to form. Our own solar system, our planet, was born from the ashes of these ancient, long-dead stars. That means the iron in your blood, the calcium in your bones, and yes, every bit of gold we prize, was seeded right here from a star that exploded billions of years ago. And this entire epic cosmic journey is what explains why gold is so precious to us. It's not just that it's shiny, it's a genuine treasure from the stars. And because of how it's made, it is unbelievably rare. So how rare are we talking? This is one of my all-time favorite facts. If you could somehow gather every single piece of gold that humans have ever mined in all of history, I'm talking from King Tut's tomb to the circuits in your phone, it would all fit inside just 3 Olympic-sized swimming pools. That's it, the whole lot. Now, to be fair, that would be an incredible amount of weight. Gold is super dense, about 20 times denser than water, so those 3 pools would hold an immense mass. But just picturing it really drives home how little of this precious stardust we've actually found on our planet. So the alchemists' dream of making gold, it wasn't so crazy after all. The universe does it all the time. Which brings us to the modern gold rush, and it begs the question, can we make more? Well, technically, yes, we can. Using huge particle accelerators, scientists can actually mimic what happens in a star and create it gold, literally one atom at a time. But look at the difference here. It's just staggering. A supernova makes tons of gold in seconds, and it doesn't cost a dime. For us to make a single gram would take eons and cost an absolutely astronomical amount of money. It's not even remotely practical. So if we can't make it, where else might we look when Earth's mines eventually run dry? Well, there's an estimated 20 million tons of gold just dissolved in our oceans, but it's spread so thin it would cost way too much to get it out. The more sci-fi option? Asteroid mining, heading out into space to tap into the raw materials of other worlds. And then, of course, there's the ultimate delivery service. A nearby supernova could shower our solar system with a fresh batch of treasure, though the radiation would also probably wipe out all life on Earth. So maybe let's stick with the asteroids for now. So there you have it. From those early alchemists to modern astrophysicists, our obsession with gold has pushed us to understand the very fabric of the universe. We followed its story from the deepest mines on Earth all the way to the explosive heart of a dying star. And it leaves you with one big question, doesn't it? Where will this eternal treasure hunt take us next?